For the last topic of our unit, we're going to look at some zeros, factors, solutions, and different parts of the graph. So let's start it off with a couple of vocabulary. If f of x is a polynomial function, all four of these statements are equivalent. Zeros, solutions, or x-intercept are the same thing. When you're trying to find a solution, you're trying to find the zeros or the x-intercept of a graph. A factor is taking your zeros or your solutions or an x-intercept and rewriting it so that it becomes a factor. It is the step before you get to the zeros. So let's take a look. For example number 1, we are on page 31 of our notes. For example number 1, it says, hey, let's sketch the graph and then actually graph it. So here's my function, f of x equals to 1/6 times x plus 3 quantity times quantity of x minus 2 squared. Well, from here, since these are already factor, these are my factor, I can find my zeros from there. I set each factor equals to 0, so x plus 3 equals to 0, and x minus 2 equals to 0. Now, this is going to give me, solving for x equals to negative 3, x equals to positive 2. Because x minus 2 is squared, there's actually 2 of them, so you can write it twice. Right? So you can write x minus 2 equals to 0, x minus 2 equals to 0, and therefore I know that I have 2 x equals to 0. And when I'm sketching this, there are a couple of things that I need to know. 1, I need to know where my zeros are. So those are my solution to this factor, which is at negative 3 and 2. I'm going to do a quick sketch, negative 3, 2. I know that the graph passes through those. And because there are 2, x equals to 2, I know the graph bounces on the 2. All right, so let's take a look. If I were to multiply these 3, there's actually going to be 3 x's. This will be x cubed. X times x times x, so x cubed. So the end behavior of this graph is actually going to be an odd end behavior. And if I'm looking at the first term, I'm multiplying 1/6 times x, those are all positive. So this will be a positive odd end behavior. That means that I know that the graph goes up on the right, goes down on the left. Now, I know that it's going to go through, so when I'm sketching it, to connect the left end behavior to the right end behavior passing through these points, I know that when I connect it, when I go to negative 3, it's going to go through, come back to 2, it's going to bounce right at the 2. So my graph is going to look something like that. Now that's a sketch because I don't have any points in the middle to make the graph more accurate. So when I'm actually graphing it, there are a couple more points that I need to find out. So I'm still graphing my 0 at negative 3 and 2. Now, to find out a little bit more point, what I'm going to do is I'm actually going to use a table. I'm going to use a table. Here's my x value. Here's my y value. I'm going to pick an x value in between the 2 zeros. And I'm going to pick 1 x values on the outside of the 0. So I know how high the hump is going to go. And I know how high or how low the two lines on the end, segment is going to go. All right, so let's take a look. I like using zeros, right? So if I were to plug in x equals to 0, I would get a point. I want to see maybe x equals to negative 4 on the other end, on the left end, and x equals to 3 on the right end. One more thing you could do, you can multiply the end caps of your factor, right? So 3 times 2 times 2. And that will give you the y-intercept. So let's take a look. Plug in 0. 0 plus 3 is 3. 0 minus 2 is negative 2. So I have negative 2 squared is 4. 4 times 3, 12. And 1/6 of that is going to give me 2. And negative 4. Negative 4 plus 3 is negative 1. Negative 4 minus 2 is negative 6. So we have negative 6 squared is 36. 36 times negative 1 is negative 36. Negative 36 divided by 6, negative 6. So at negative 4, it'll be at negative 6. And at 3, well, x equals to 3. 3 plus 3 is 6. 3 minus 2 is 1. So 1 squared is 1. 1 times 6 is 6. And divided by 6 is 1. So I have a couple of points with me. So I go 0, 2. So that's where it goes through right there. Negative 4, negative 6. It goes a little slightly off the graph. And 3, 1. So now, using the shape of my graph, I can draw the actual graph. It goes in, comes out, curve, right back in. That's my graph. It's a little bit more accurate because I gave it a little bit more points.